Forget the intro. Here it is. Number 6. The Great Attractor, the silent gravitational ghost at the center of our cosmic web. According to the standard model of cosmology, the expansion of the universe is governed by the Hubble flow. In a perfectly smooth and isotropic universe, every galaxy should be receding from every other galaxy at a predictable rate proportional to its distance. This is the comforting interpretation of natural order, a uniform, predictable expansion where gravity works locally, but the big picture is a gentle, outward drift. For decades, we used to think that on the largest scales, the universe was as featureless and predictable as a calm ocean. But in 1986, a group of astronomers known as the Seven Samurai were mapping the peculiar velocities of elliptical galaxies when they discovered an impossible tug. Led by researchers like Alan Dressler and Sandra Faber, they found that the Milky Way and thousands of other galaxies aren't just drifting. They are being pulled. They detected a massive gravitational anomaly roughly 250 million light-years away, hidden behind the gas and dust of our own galactic disk in an area called the zone of avoidance. According to the cosmological principle, matter should be distributed evenly, meaning no single region should have enough mass to pull an entire supercluster across hundreds of millions of light-years. This violates the very principle of homogeneity. The Great Attractor exerts a pull equivalent to tens of thousands of Milky Ways, a mass of approximately $10, $16 solar masses. The math doesn't add up because this region, located in the direction of the Centaurus and Norma clusters, shouldn't be dense enough to anchor the Laniakea supercluster. There is no known mechanism in standard general relativity that accounts for such a localized concentration of mass without a visible source that matches the magnitude of the gravitational effect. Imagine you are a passenger on a ship in the middle of a fog-covered ocean. You expect to drift with the current, but instead you feel a steady, unrelenting pull toward a point you cannot see. The water isn't moving, but your ship is, sliding at 600 kilometers per second toward a massive invisible drain. You'd feel the realization that the map you were given is wrong. The horizon isn't empty. It is like discovering a magnet under the floorboards of the universe, dragging everything into the dark. But it gets worse. When scientists finally used X-ray astronomy to look through the dust, they found something even more unsettling. The Great Attractor isn't the final destination. The horror deepens when you realize that even it is being pulled. Our entire region of space is flowing towards something even more massive, the Shapley supercluster, located 650 million light-years away. If the Great Attractor is a localized glitch, the Shapley concentration is a systematic error in the architecture of space-time. If you were to look out from a planet in the Norma cluster, at the heart of the attractor, you would see galaxies colliding and shredding each other in a frantic, crowded dance of light. But you wouldn't know why. You would experience the visceral horror of being part of a celestial stampede where the exit is invisible. Your home is part of a 500 million light-year structure that is fundamentally untethered. You're alone with the impossible. These phenomena are gravitational shadows cast by a structure we can't fully see. They prove that our perspective of the cosmos is limited by the very galaxy we live in. We are the surface dwellers claiming to understand the whole house, while the foundation is shifting beneath our feet. Number 5. The Dipole Repeller, the invisible wall of nothingness that is actively pushing our galaxy away. In the field of science, we understand gravity as an attractive force. General relativity tells us that mass curves space-time, drawing objects toward one another. For decades, the motion of galaxies was explained solely through these pulls. We assumed that if a galaxy was moving, it was because something heavy was attracting it. This is a safe baseline. The universe is a series of weights pulling on a fabric. It's as well understood as a ball rolling down a hill. But in 2017, a team led by Yehuda Hoffman at the Hebrew University of Jerusalem and Brent Tully at the University of Hawaii discovered something that broke the pull-only model. By mapping the three-dimensional flow of galaxies using the Cosmic Flows 2 dataset, they found that the Milky Way isn't just being pulled, it is being pushed from behind. They identified a vast, empty region of spacetime that they named the Dipole Repeller. According to the law of universal gravitation, a void, literally a place with nothing in it, should not be able to exert a force. Physics says that repulsion requires either a negative mass or a specific pressure, like dark energy. However, the Dipole Repeller acts as a center of effective repulsion. The numbers show that the push from this void is almost equal in magnitude to the pull from the massive attractors. The Milky Way is traveling at 631 kilometers per second relative to the cosmic microwave background, and nearly half of that velocity is generated by this empty space. This breaks known laws because nothing is acting as a physical actor in the geometry of the universe. Imagine you are standing in a crowded room, being pulled toward a buffet table. That's the Great Attractor. But then you realize that the person behind you, who isn't even there, is pushing you forward. You feel a cold pressure against your back coming from a doorway that leads to an empty, dark hall. You'd know, with a sudden chill, that the absence of a thing is just as powerful as the thing itself. But it gets worse. The Dipole Repeller isn't just a small pocket of emptiness. It is a supervoid that spans hundreds of millions of light years. Even more unsettling, researchers found a second similar structure called the the cold spot repeller in late 2017. This means that the large-scale structure of the universe is not just a web of matter, but a V-web of voids that actively steer the flow of galaxies. If space-time is a fabric, then these repellers are areas where the fabric isn't just thin, it's actively pushing back. If you were to be stranded in the center of the dipole repeller, you would be in the most isolated place in existence. There would be no stars and no light for millions of light years in every direction. You would experience a sensory horror, where the vacuum isn't just a lack of air, but a lack of existence. You are drifting in a hole in reality. These repellers are glitches in our understanding of force and mass. They prove that the nothing between the stars is just as vital as the stars themselves. We are explorers who've mapped the peaks of the mountains but ignored the depth of the ravines. Number 4. The CMB cold spot. The anomalous bruise on the very edge of the observable universe. The cosmic microwave background, or CMB, is the afterglow of the Big Bang, generated when the universe was only 380,000 years old. Standard models tell us that this light should be almost perfectly uniform, with temperature fluctuations of only about 1 part per million. This is the ultimate baseline reality, a smooth, warm background that proves the universe expanded equally in all directions. It's the echo of creation, and it's supposed to be symmetrical. But in 2004, data from the Wilkinson Microwave Anisotropy Probe, or WMAP, revealed a massive anomaly in the constellation Eridanus. Astronomers found a region of the sky that was significantly colder than the rest, about 70 microkelvins below the average. In some parts, the temperature drop is 140 microkelvins. This cold spot is massive, spanning about 5 degrees across the sky, or about 10 full moons lined up side by side. According to Gaussian statistics, a spot this large and this cold has less than a 1% chance of occurring naturally. Physics says that the distribution of heat should be random, but the cold spot is a structured deviation. The math doesn't add up because even a supervoid 1.8 billion light-years across would struggle to explain such a deep drop in temperature through the integrated Sachs-Wolf effect. There is no known mechanism in standard inflation that creates such a massive, singular glitch in the initial conditions of space-time geometry. Imagine you're looking at a high-resolution photograph of a clear blue sky. It's perfect and serene. But then, you notice a single, dark, jagged thumbprint in the corner. It's not a cloud. It's a part of the sky itself that is just wrong. You'd feel a sense of dread, knowing that the perfect image is actually a mask for something underneath. It is like finding a dead pixel on the monitor of reality, a place where the light simply didn't work. The horror deepens when you consider the competing theories. If it isn't a supervoid, some physicists suggest it could be a cosmic bruise, a point of contact where our universe collided with another one during the inflationary period. Even more unsettling, if this is a remnant of a phase transition, it means space-time geometry has defects, like cracks in an ice cube. If our universe is just one bubble in a multiverse, then the cold spot is the place where the wall is thin. If you were to travel toward the cold spot, you would be entering a region where the density of matter is so low that the concept of place begin to fail. You would experience the visceral horror of a void that doesn't just lack stars. It lacks the fundamental heat of our birth. You are walking to a cold room that was never meant to be opened. These phenomena are living question marks on the map of eternity. They prove that the universe is not as perfect as our equations demand. We are children convinced the closet is empty because we haven't opened the door. Number 3. The fine structure constant variation. Glitch in the fundamental code of physics. In the field of physics, we rely on universal constants. The fine structure constant, denoted by the Greek letter alpha, is a number approximately equal to 137th. It governs the strength of the electromagnetic force, the very thing that keeps electrons orbiting nuclei. Standard models tell us that these constants are the same everywhere in the universe and at all times. This is the comforting interpretation of the natural laws. They are immutable, fixed, and reliable. Physics is supposed to be the same in your backyard as it is in a distant galaxy. But in 2020, Professor John Webb and his team at the University of New South Wales used data from the Very Large Telescope to analyze light from a quasar 13 billion light-years away. They found something that shouldn't be possible. The value of alpha wasn't constant. By using new AI analysis methods on the spectra of the quasar J1120 plus 641, they discovered that the electromagnetic force seemed to vary depending on which direction they looked in the sky. According to Einstein's equivalence principle, the laws of physics must be local and invariant. However, Webb's data showed a spatial variation in alpha at the 3.9 sigma level. The numbers show that in one direction, electromagnetism is slightly stronger, while in the opposite direction, it is slightly weaker. This breaks the fundamental geometry of space-time because it suggests the universe has a preferred direction, or dipole. If alpha changed by even 0.002%, stars would be unable to fuse helium, and life as we know it would be impossible. Imagine you are a programmer looking at the source code for a massive simulation. You expect the gravity and light variables to be global, but then you find a line of code that says the rules change if the character walks too far to the left. You'd feel a surge of panic, realizing the simulation is unstable. You'd know that the world isn't built on logic, but on a series of local patches. But it gets worse. If the fine structure constant varies, it means that other constants, like the speed of light or the mass of an electron, might also be local variables. This suggests that our part of the universe is just a habitable pocket where the laws happen to allow for atoms to stay together. If you were to travel far enough in the wrong direction, your own body would literally dissolve, as the electromagnetic force becomes too weak to hold your molecules together. We aren't just in a vast universe, we are in a minefield of shifting physics. If you were to jump into a ship and travel 15 billion light years toward the weak pole, you wouldn't notice the change at first. But slowly, your electronics would begin to fail. Then, your DNA would start to unspool. You would experience the horror of your own existence being uncoded by the geometry of space. You are alone in a place where you are no longer allowed to exist. These anomalies are reminders that we are not the masters of reality. They prove that the laws of nature are just local habits. Number 2, the Big Ring, a geometric impossibility etched into the very structure of the cosmos. In standard cosmology, there is a theoretical limit to how large a structure can be. According to the scale of homogeneity, any structure larger than about 1.2 billion light-years should be impossible because there hasn't been enough time since the Big Bang for matter to clump together on such a massive scale. We used to think that the universe becomes smooth once you look at it through a wide enough lens. This is the comforting baseline. The universe is like a bowl of soup, lumpy up close, but perfectly uniform when you step back. But in January 2024, PhD student Alexia Lopez from the University of Central Lancashire announced the discovery of the Big Ring. Using light from distant quasars to map magnesium-2 absorption lines, she found a ring of galaxies and galaxy clusters 9.2 billion light-years away. The structure has a diameter of 1.3 billion light-years and a circumference of nearly 4 billion light-years. It appeared on the monitor as an almost perfect coiled spiral of matter where there should be nothing but an empty void. According to the cosmological principle, this structure shouldn't exist because it exceeds the size limit by a significant margin. Physics says that gravity simply hasn't had the time to pull that many galaxies into a coherent ring shape in 13.8 billion years. It violates the principle of isotropy, as it sits in a specific region of the sky near the constellation Bootes. There is no known mechanism in the standard model that can produce a structure this large and this geometrically precise. Imagine you are looking at a satellite map of the Sahara Desert. You expect to see random dunes and flat sand, but then you see a perfect glowing circle of stones, hundreds of miles wide, sitting in the middle of the wasteland. You'd know immediately that the wind didn't put them there. You'd feel a sense of profound wrongness, knowing that the natural processes you understand couldn't have created such a shape. It is as if someone has taken a compass and drawn a circle on the face of the deep. The horror deepens when you realize that the Big Ring isn't alone. It sits just 12 degrees away from the giant arc, another impossible structure. Together, these two ultra-large structures cover a massive portion of the sky. This means the universe isn't just lumpy, it is organized. Some theory suggests these rings could be bruises from a previous universe that existed before the Big Bang. If that's true, then the Big Ring isn't a structure, it's a scar. Are we living in the wreckage of a dead reality? If you were to stand on a planet within the Big Ring, the night sky would be dominated by a wall of light that stretches across the entire horizon. You would feel the weight of the impossible, knowing that your home is part of a pattern that defies the very history of time. There is no rescue from the realization that the universe's origin story is a lie. You are looking at a structure that is older than the time allowed for its creation. You are a ghost in a machine that has no manual. The Big Ring is a living contradiction in the geometry of space. It proves that our standard model is more like a standard guess. We are cartographers who've mapped distant galaxies but failed to see the giant symbols they form. Number 1. The giant arc. The 3.3 billion light-year long crack in the foundation of modern cosmology. For decades, Einstein's cosmological principle has been the bedrock of astronomy. It assumes that on a large enough scale, the universe is homogeneous and isotropic. This is a comforting interpretation of reality. It allows us to use math from our corner of space to describe the edge of the universe. We used to think that the cosmic web was a random, tangled mess with no overarching architecture. This uniformity is what makes the universe feel like a coherent, single entity. But in 2021, Alexia Lopez discovered a structure so large it made every other anomaly look like a footnote. The giant arc is a symmetrical crescent of galaxies that spans 3.3 billion light-years. It is located 9.2 billion light-years away in the constellation Bootes. It was found using the same magnesium absorption method, revealing a massive, glowing spine of matter that stretches across 1/15 of the entire radius of the observable universe. According to the theoretical limit of 1.2 billion light-years, the giant arc is nearly 3 times larger than what physics says is possible. The math doesn't add up because the probability of such a structure forming by random chance is virtually zero. It breaks the cosmological principle entirely. If the universe isn't homogeneous on this scale, then our fundamental equations for gravity and expansion might be based on a false assumption. There is no mechanism to explain how 3 billion light-years of matter decided to line up in a perfect arc during the first few billion years of existence. Imagine you are an ant on a large, smooth marble floor. You've spent your life believing the floor goes on forever in a flat, white expanse. But then you look up and see a massive, jagged crack that spans the entire room from one wall to the other. You'd realize that the floor isn't a solid foundation. It's a fragile surface that is breaking apart. You'd feel a crushing sense of insignificance, knowing that the world you thought you understood is just a small, unbroken patch on a shattered whole. It's like seeing the skeleton of the universe through a rip in the skin. But it gets worse. The giant arc and the big ring are in the same cosmological neighborhood. This suggests that there is a superstructure that we haven't even begun to name. Even more terrifying, if these structures are real, it means our understanding of dark energy and dark matter could be entirely wrong. We might be living in a universe that isn't expanding uniformly, but is instead being warped by massive geometric glitches that we are too small to see. Is it possible that the universe isn't a sphere, but a fractured geometry of arcs and rings that serve a purpose we can't fathom? If you were to see the giant arc from a distance, it would look like a ribcage of light holding the universe together. But you would be too small to ever see the whole thing. You would experience the personal horror of knowing you are part of a structure so vast, your entire civilization's history is less than a microsecond on its timeline. You're living on a speck of dust on a crack in a window. There is no warning when the glass finally shatters. You're staring at the architect's blueprint and realizing your house was never meant to be finished. The giant arc is the ultimate reminder that the universe is under no obligation to be simple. It proves that our laws are just the stories we tell ourselves to sleep at night. We are the surface dwellers claiming to understand the house, while the giant arc proves that the house is a mansion with rooms we aren't allowed to enter. Our understanding of the universe is a map made of shadows and half-truths. These 6 glitches prove that space-time is not a smooth fabric, but a fractured, moving, and terrifyingly complex structure. We are just beginning to see the cracks. If you want to keep staring into the void until it stares back, hit that subscribe button. Okay, that's it for this one. If you enjoyed it, you know what to do.